Hello and welcome back for section 6.4 on graphs of sine and cosine functions. Alright, so we'll start with a bigger table for f of x is, we'll just do the basic sine x first, and we'll see what that looks like, and then we'll boil it down to sort of a simpler, cleaner sketch. So x, that's going to be sort of our theta, and the resulting sine x. So sine of 0 is still 0. Sine of pi over 6, so remember that's 30 degrees, would be 1/2. Sine of pi over 4, that's, remember, 45 degrees. Root 2 over 2. 60 degrees, that's pi over 3. And that is root 3 over 2. And 90 degrees, pi over 2. Sine is at 1. And then everything after that is just sort of reflecting or rotating on those points. So next up, let's see, pi over 2 plus pi over 6 would be, let's see, 4 pi over 6, so 2 pi over 3. We're back at down to the root 3 over 2. 90 degrees past pi over 4 would be 3 pi over 4. And we have a height of root 2 over 2 again. And then 60 degrees past the pi over 2. And we are at, let's see, then we would be at 5 pi over 6, yeah. And we're down to 1/2. And 6 pi over 6 would be just pi, and our sine, the y value, is back down to 0. And then we just keep adding 30s, 45s, and 60s beyond that. So pi plus 30 degrees, 6 pi over 6 plus 1 pi over 6 is 7 pi over 6. Now our sines are in Q3 negative territory. So now we're talking about, on the unit circle, negative sine values. So that would be at negative 1/2. Pi over 4 past pi would be 4 pi over 4 plus 1 pi over 4, so 5 pi over 4. And we're at negative root 2 over 2. Pi over 3 plus pi would be pi over 3 plus 3 pi over 3 would be 4 pi over 3. And we're at negative root 3 over 2. And then we're down at 3 pi over 2, so that's the 270 degrees. And our sine value is negative 1 there. And then we get into Q4. So 3 pi over 2 plus pi over 6. So 9 pi over 6 plus 1 pi over 6 is 10 pi over 6, which is 5 pi over 3. And our sine value, we're back at negative root 3 over 2. 3 pi over 2 plus the 45 degree angle. 6 pi over 4 plus 1 pi over 4 is 7 pi over 4. And negative root 2 over 2 for a y value, and then 3 pi over 2 plus our pi over 3. So that would be 9 pi over 6 plus 2 pi over 6, so 11 pi over 6. And our sine value is down to a negative 1/2. Once we get to the 2 pi, we're back around to the 0, and our output is 0. We already know what that looks like on a unit circle. Let's take a look at it on a graph. Again, you'll sort of use our imagination here since I don't have the nice neat smart board like at the front of the classroom to use. So sine of 0 is 0. And let's see, we'll bring this out to, we'll do two full cycles. So we'll make this guy a 2 pi. So this guy will make a 4 pi. So this guy is a pi, 3 pi. And we'll pretend that I've spaced them evenly. So pi over 2, 3 pi over 2, and so on. So we'll start with this first cycle in here. So we have pi over 6 is at a half. So we'll make this a half, and this will be our 1. So we're at a half, root 2 over 2. Root 3 over 2, and up to the 1, and then we come back down. Root 3 over 2, root 2 over 2, 1/2, and down to 0. You have to use, again, a little imagination since I'm freehanding this in. And then we just pop below the axis as well. So there's our 30 degrees past pi, 45 degrees past pi, and 60 degrees past pi. And then we're at the 270. And again, we turn around. So this is one full cycle. 2 full cycles. Remember, after 2 pi, we're just basically making another lap around the unit circle. So what we do is kind of concentrate on these 5 key points when we're sketching the graph. What happens at 0 degrees, 90 degrees, 180 degrees, 270 degrees, and then back around to the original. So what happened at pi is now happening also at 3 pi. What happened at 2 pi is also happening at 4 pi. What happened at pi over 2 is now happening at 2 pi plus pi over 2. What happened at 3 pi over 2, 3 pi over 2 plus 2 pi, that's happening again. And we have another cycle, and that would just keep happening forever in both directions. We keep cycling between +1, -1, bouncing back and forth the whole time. So that's if they want 2 full cycles. Now, all of the shifting, stretching, compressing, reflecting, all that stuff that you learned in college algebra with your other functions, yeah, we're still going to be able to do that. So for example, if I want y equals, we'll start with just 3 sine x. So recall that a times f of excuse me, a times f of x is just the original graph multiplied by a for each y output. So we'll do just 2 quick cycles of that. So I'll start with just the sine x, and then we'll draw in 3 sine x. And I am going to ask you to do some of these sketches by hand. So again, we'll do 2 cycles of just the major points. So here's at 2 pi, here's at 4 pi, pi over 2, 3 pi over 2, 3 pi, and then 2 pi plus pi over 2, 5 pi over 2. and 3 pi over 2 plus 2 pi would be 7 pi over 2. Alright, so here's our 1, 2, and 3, 1, 2, and 3. So sine of 0 is 0, sine of 90 degrees is 1, sine of 180 degrees, we're back at 0, sine of 270, we're back at -1, sine of 2 pi, we're at 0, and then that pattern repeats. So up to 1, down to 0, down to -1, back to 0. So here is our original function, and then we'll take into account the 3 on the next one. Most books tend to forget the arrows on the end, but the pattern continues. It's a pattern that keeps going forever in both directions. It doesn't come to a stop on those points. So remember, this 3 is just taking our old y values and tripling them. Well, 3 times 0, we're still at 0. But 3 times 1, now we're at 3. 3 times 0 is still 0. 3 times -1, now we're down here at -3. So we multiply all of our old outputs by 3. That's just from your college algebra and even intermediate algebra days. So we just turn the amplitude up on this. So there's 2 full cycles. Another one that you hopefully remember, sine of half x. So remember, what's inside the argument sort of works backwards from how we think. So we're multiplying by a half inside, which means I would have to double the x values to get the same output that I did before. So where I used to have to go just to, let's say, 2 pi, now I have to go to 4 pi to get a full 2 cycles, or full 1 cycle out of this. 8 pi if I want 2 cycles out of it. Alright, so we're eventually going to want 2 cycles out of this, so we'll make that guy our 8 pi. Half in between is our 4 pi then. 6 pi there. 2 pi. Pi, 3 pi, and so on. So pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, and so on. So notice these also fit into the pi over 2 is 8 pi over 2 is the same as 4 pi and so on. So we'll start with 2 cycles of our just y1 graph. Y1 is, this is built off of a sine function. So sine of 0 is 0, sine of 90 degrees is 1. And let's see, we're really only going to go from -1 to 1. So there. Sine of 180 degrees are back at 0, 3 pi over 2 back at -1, 2 pi we're at 0. So there's 1 cycle, and we'll go a second cycle as well. So here's our first 2 cycles of the sine function. Alright, to get a 0 in here, half times 0 is still 0. This guy is still nailed down where he was. To get a let's say pi inside, I would have to go to 2 pi. To get a pi over 2 in there, I'd have to go to pi to get that done. So everything is taking basically twice as long to do. To get a 3 pi over 2 in there, I have to go to 3 pi. To get the 2 pi in there, we've got to go to 4 pi. So there's our first cycle. And then the second cycle would basically do the same thing again. So to get to the 5 pi over 2, I've got to get to the 5 pi. Half times 5 pi is 5 pi over 2. To get to 3 pi, I'd have to go to 6 pi. And to get to 7 pi over 2, we'd have to again go to 7 pi. To get to 4 pi, we'd have to go to 8 pi. So here's our second cycle. So this time, instead of stretching it vertically, we stretched it horizontally. So multiplying by something greater than 1 in absolute value outside, we'll stretch it vertically. Multiplying by something smaller than 1 in absolute value, of course non-zero, we would stretch it horizontally. So all of those things that you used to do back in your college algebra days, we're still doing them with the sines and cosines. We'll do maybe one more of these. We'll do y is -3 sine of 2x. So let me set this up, and I'll ask you to pause the video and try it out. And again, remembering that you're going to be asked to do these sans calculator. So be prepared to be able to sketch those out. Okay, so pause the video and we'll finish it out together. Okay, welcome back. I can already see, I know that sine is between -1 and 1, and I can see I'm multiplying by something with an absolute value of 3. So instead of going just between -1 and 1, I know eventually I'm going to go to 3's and -3's on the extremes. This time we multiplied by 2 inside, so this is actually going to compress the graph. So if I want my 2 cycles of the original, I've got to go to 4 pi. So here we'll just set the 2 pi here. So about the same length. So here's our 4 pi and there. So there's our pi and 3 pi, and cut those guys in half. So 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2, 7 pi over 2. Alright, so I'll just start with the basic sine function, and these, we've got the room, so we'll just 1-to-1 scale for the vertical axis this time. So 2 full cycles. Just picture clicking around the unit circle 90 degrees at a time, what's happening to your y values. So then on y2, sine of 2x, well, 2 times 0 is still the 0 that we had here, so this point is still nailed down. To get to pi over 2, I'd only have to go to pi over 4. 2 times pi over 4 is pi over 2. To get to pi, we'd only have to go to pi over 2. Pi had an output of 0, so now at pi over 2 we have an output of 0. Same thing here. To get to 3 pi over 2, I only have to go to 3 pi over 4. Okay. To get to 2 pi, I only have to go to pi. So there's one cycle already. So now it's half the size instead of twice the size. And then that will happen one more time. So here's 2 complete cycles. And we'll just do our arrows on the end. So we took the black graph and we compressed it this time into that red graph. And just one more change on here. So this one, it's outside of the argument. So it's just multiplying our old y values from the previous stage, not the original, the previous stage, by -3. Well, 0 times -3 is still 0, but 1 times -3 is -3. 0 times anything is 0. -1 times -3 is +3. 0 times anything is 0. 1 times -3 is -3. 0 times anything is 0. -1 times -3 is +3, and so on. So there's 2 cycles. So we've been vertically stretched, flipped, you can also refer to it as reflected. And, oh, need to finish this guy. We'll come back down to 0 there. Almost forgot my last point there. So there is 2 full cycles of our y is -3 sine of 2x. So just keep track of it, change one thing at a time, and it's the same rules that you had back in your college algebras as far as changing it. Alright, so next we get to play with the cosine function. Same ideas as the sine function, so we'll run through it a little bit faster. All the same ideas. So y equals cosine of x. So x, remember, is our theta, and cosine x. So cosine of 0 is 1. Cosine of pi over 4 is √3 over 2. Pi over 3, my goodness, I'm rushing myself here. Pi over 3, 60 degrees. Pi over 6, what is wrong with me today? Pi over 6 is √3 over 2. Pi over 4, √2 over 2. Pi over 3. And that is our 60 degrees. Our cosine is now just at 1/2, and pi over 2, we're at 0. And so on. So we just cycle through that until we hit the 2 pi. Again, I'm not going to go through every single point. You know your unit circle by now. I want to kind of run through what a cosine graph looks like. And we'll again do 2 full cycles. So remember, cycle is for sines and cosines 2 pi in length. So here's our 1 and -1. So cosine of 0 is 1. So instead of starting on the origin, this time we start on 0, 1. At 90 degrees, we're back down to 0. And we still have these other smaller points in between that give us the nice, neat curve going. At pi, we're down to -1, 3 pi over 2, we're back to 0, 2 pi, we're back at 1. And then here's our, for example, halfway in between that is root 2 over 2. So we have our nice little curve here. And in calculus, you'll get to study the slope of that a little more. So this is what one full cycle of the cosine looks like in the xy plane as opposed to on the unit circle. So then we just do that again. 0, -1, 0, and +1. So there's 2 cycles of our buddy the cosine. So we'll just do maybe one more, flip it, make it a little easier to read. We'll do y is -4 cosine of, we'll do 2x. So the graphs that we'll need, y1 will be cosine of x, y2 will be cosine of 2x, and y3 will be the whole thing. So I know with this 2x that I am actually compressing horizontally. So if I want 2 cycles of this thing, for the original, I have to go to 2 pi for one cycle, 4 pi for the second cycle. But then when I compress it, I'll have 2 full cycles just from 0 to 2 pi. And again, our scale of 1 on the y-axis. Alright, I'll do the original in black. So cosine of 0 is 1, cosine of 90 degrees is 0, cosine of pi is -1, 3 pi over 2, we're back to 0, 2 pi, our cosine is 1. So just picture clicking around the 4 compass points of your unit circle, and then we do it again. So here is our just basic function of y is cosine x, and not basic as in that this stuff is easy, basic as in there was only one thing happening to our input. It was made into the argument of a cosine. So then this one tells me we are compressing, so all of our points are halfway in from where they were on the x-axis. So what happened at 0 stays at 0, but what happened at pi over 2 is now happening at pi over 4. What happened at pi is now happening at pi over 2. What happened at 3 pi over 2 is happening at 3 pi over 4. What happened at 2 pi is happening at 1 pi. So here's our first cycle of the cosine, and then we do it again. And in blue, then we'll account for this -4. Multiply all of your output values by -4. So 1 times -4 is -4. 0 times anything is 0. -1 times -4 is +4. 0 times anything is 0. 1 times -4 is -4, and so on. So now here is our compressed horizontally and stretched and reflected vertically sketch of the cosine function. So just a little bit of vocab that we used in that section. A cosine of x or a sine x, a is the amplitude. And we can just use absolute value so that we just care how much it was dragged out, not necessarily did it get flipped or not flipped. That letter there that looks kind of like a curly W, that's actually a lowercase omega. And that helps us figure out the period. For sines and cosines, remember the original is 2 pi. They use a cap T for period. 2 pi divided by whatever omega is. So for example, on this one, 2 pi over 2, one full cycle was completed by pi. For the other one where we stretched it horizontally, 2 pi divided by a half is really 2 pi times 2, so that's why we had to go to 4 pi for a single cycle of that other one. Alright, so some problems to try out. This was, again, section 6.4. If you're doing the textbook ones, 3 to 10 all, 11 through 21 odd, 23 to 32 all, and 33 to 69 every other odd. And then I'll find some equivalent ones on my MATLAB for those of you that prefer my MATLAB version. Alright, any questions, please feel free to get in touch with me. Otherwise, stay safe out there, and I'll see you next video.